I would like it so it's just I've lost my pen. It's just working through them, and even if you only get through 4 questions, I'd rather get through 4 and you kind of fully see the process of us answering them rather than try and whiz through them all and say, oh yeah, da-da. And what we'll do, rather than share it in the group, we'll just share it between me and you. So basically, the more we can work through these together, the better. I'm gonna get my pen. Can I? I'm going purple. And purple's my favourite colour, so I'm gonna go purple. Right. And these are obviously all based from questions that are on the most recent exams. We've got non-calculator, non-calculator. Quite a lot of the, what I'd say, low tariff questions, 2 points and stuff that are with fractions and decimals will be on the non-calc because it's kind of getting you to use a bit of mental math. So Mr. Aldridge has his students to compare distances of galaxies from the Milky Way, the distances between galaxies, and this is what I don't like about these sort of questions. Because for starters, I'm not interested in Milky Way. Well, Milky Way, yeah, the sweets, but galaxies and galaxies actually, yeah. So maybe I am. Distance between the galaxies are measured in megaparsecond units. So that's if I'm reading this question for the first time, that's probably already made me think this is going to be tricky because I don't know what that is. But Andromeda galaxy is 0.752 megapar from the Milky Way, and the pinwheel is 5.1 times further than the Milky Way. So this question is asking us what? But what's it asking us to do? It's asking us to look at that distance there and times it by that distance there, because that's 5.1 times further, and it's asking us to do it into 2 decimal places. So if I see this question on a math paper, so 0.752 multiplied by 5.1, I can do it. But when I read all this rubbish around it, I'm thinking, wow.
It becomes confusing.
Yeah, it's just the words. Yeah, I get what they're trying to do, and I do get it, but I just get lost in all the words. So when we do a question like this, what we're going to do, we're going to multiply that one by 10, 20, 10, 100, 1,000. So we're going to move decimal place 3 times to the right. Okay, so that becomes 7, 5, 2. Then we're going to move this one once, so that's 1 place. So altogether we've done 4 decimal place moves here, and that's now doing 51. So when I see that question, I see it as a normal double multiplication where we've got the 0 here and we times it by 10. So we've got that. So if we work it out like that and then put the decimal places back in, I forget about megaparseconds, Milky Ways, galaxies, pinwheels. I'm just doing the math, and so it becomes a straightforward 2 times 1, 5 times 1, 7 times 1, and then we put the 0 there because we're timesing by tens, so that would be there. 2 times 5 is 10. 5 times 5 is 25. Add our spare, 26. And then 7 times 5 is 35. Add our spare, it's 37. So we've now got 2 columns to add, 2 rows to add up, and we add them straight down in the columns. 13 with 1 to spare, 7, that becomes an 8, and that is still 3. So now we've got to figure out, we've got an answer of 38,352. Well, if we looked at the question to start with, 0.7 times by 5, so the number's going to be less than 5 because it's saying 0.7 times 5, and we said here we cut 3 and then 4, so 4 decimal places out, so decimal places here, so we put it 4 places back in, 1, 2, 3, 4, and we just said that the number's going to be less than 5 because we're timesing it by 0.7, so that fits. It's not 38 because that would be 7 times 5, so the answer becomes 3.835. However, 2 decimal places, that 3 is the decider, because that's the second number after the decimal place. And as it is, sorry, the third number after the decimal place is the decider, and as it's a 5, that goes up to a 4. So that becomes 3.84. God, my pen seems really sharp today, as in like it's not flopping about, it's looking good. So that's the answer. We kind of take out all of the rubbish, all of this mess, and we concentrate on the numbers. And I'd encourage anybody to do that for any question, because it's the process of what we're doing, not talking about megaparseconds or galaxies or Milky Ways or anything like that. So NASA lost a spacecraft due to confusion between imperial, and this is non-calculator still, between imperial and metric units. A length of 2 3/4 inches was read as 2 3/8 centimeters. 2 3/8 inches equals 6 13/400 centimeters. Work out 6 13/400 minus 2 3/8. So that is a straight maths question. We don't care about NASA. We don't care about imperial units, metric units. Oh, I slipped yesterday when I was mopping my floor. I don't know if I was dancing with the dog or dancing with the mop, but my sciatic nerve was just, I hurt it quite a couple of years ago. I hurt it quite badly, and I was bedridden, but it's just tweaking today. So I'm having to sit bolt upright in my chair. Oh, it just sometimes gives me a little bit of a shock. So if you see me wincing, it's because it's just told me to sit up straight. So we've got the full-on mixed numbers here. So what we first need to do is change them to improper fractions. Change to it keeps moving. How weird is that? Improper fractions. And the way we change things to improper fractions is we do the full pizza, 6, multiplied by the slices that are in each pizza, 400, and add the number of additional slices we've got left. So 6 times 400 is 2,400. So let's do 6 times 4 is 24, add the 2 zeros on the end. So 2,400, add our spare 2,413 slices, and it's still a pizza made up of 400 slices. The denominator stays the same. Oh, I do like this purple pen. Either my nib on my pen's gone sharp and it's making my numbers not go all squiggly, or purple is better. And then the next one, we've got 2 full pizzas times by 8 slices, that's 16. Add our spare slices on top, that becomes 19. So that pizza is 19/8. So we've done that part, but we still can't see any relationship there because we haven't got the same denominator. So we need to make these two numbers the same. And the easiest way to do that is to make this one go to 400ths as well, which is a bit of a, for 2 marks, I think this is a bit of a long-winded one, but it's worth doing it. So we're going to put 400 there. And whatever we times this one by to get to 400, we're going to times this one by. So if we did 8 times 5, that equals 40. So it must have been 8 times 50 equals 400. So we did it times by 50. So we've also got times 19 by 50. And I'm not brilliant at my 19's timetable, so I'm going to go 19 times 5 and stick a 0 on the end. Like I did here, just did 8 times 5, stuck a 0 on it. So 19 times 5. 9 times 5 is 45. 1 times 5 is 5. Add me 4. That becomes 95. And I'm going to put a 0 on the end because it's 50. So I now know that I've got the same denominator. I've got the same number. Now I can just do it easy. I know my number is going to be 400ths because the number at the bottom doesn't change. It's just saying take away 2,413 and then 950 underneath it. So it's saying do that as a takeaway sum. So 3 take away 0 remains 3. 1 take away 5 we can't do. 11 take away 5 we can do now. That's 6. 3 take away 9 we can't do. So 13 take away 9 we can. And then 1 take away 0 remains at 1. So we've now got the number of pieces back as an improper fraction. But we need to make it back into a mixed number. I can't remember if the answer gives you it as that number. But we're going to say it doesn't because I can't remember if it did or not. So we're going to change it back into a mixed number. So we look at our pizza of 400 slices. So 400, add another 400, add another 400, add another 400. Okay, so we can clearly see that we've got 3 full pizzas here because that's 1200 and that's 14. So we've got 3 full pizzas. And now we need to know the difference between this number and this number. So if we go over here and look at it, we should be able to do it without doing the full takeaway.
263.
Yeah, absolutely. 2, 6, 3, 400 pieces of pizza. Okay, so we've got 3 full ones and my brain's not working now. 3 full ones and 263 pieces of pizza. And it's 400ths. So that's the answer. We've put it back into a mixed fraction, a mixed number. We've got the full ones and the parts.
But if you stop without putting it into a mixed fraction, is it going to be wrong, or can they still give it?
Let's have a look, because I can't remember if it does make you put it back into that or not. So let's go on to it and find out. Actually, oh, it does that all the time. Move that black thing out of the way. It always comes up, and then I press something and it like changes the layout of my screen. Wish it could just could appear somewhere else. Let's have, what paper is it first? My answer, it is 2138 question 1G. 2138 1G. 2138 2138 G. Right, let's have a look. 2138 1 D E F G. Yep. So it lets you look. It's letting you, and if you can't see the screen, I apologize, but yes, it's letting you put it back into. It's saying it'll give you the full mark if you put 1,463 400ths, which is what we got before we switched it into a mixed number, or like it says here, 3 and 263 400. So you're getting your points for either of those, and I think that's right because it's only a 2-pointer, and you've done a lot of workings out in the fact that you've changed them both into impropers, then you've changed it into the same denominator at the bottom, and then you've done the takeaway. So you've done more than 2 marks worth of math there. And so it's one of those sort of questions where you think, well, I know how to do it. It's going to take me a bit of time. So that probably did take us 4 minutes. So we probably ate up our full allocation of marks there. Whereas that one probably wouldn't have, because it was just a straight multiplication once we figured out all this rubbish writing. But sometimes you get questions like that where you think, I know how to do it, and I'm going to spend my time. I'm going to spend the limit on it. I'm not going to spend 10 minutes doing it. I was going to try and cross my leg to try and give it a stretch, but it's right. Tanya wants to set up her own small business. She reads that. Let me just scroll that down a little bit. She reads that at the start of 2021, there were 5.544 million businesses in the UK. 124 out of 125 of them were small businesses. Work out 124 25ths of 5.44. Give your answer to 1 decimal place. So that's the important bit, 1 decimal place. This is just asking you for a fraction of a number. You know, it could say 3/4, it could say 7/10, it could say whatever, but it says 124 125th. So we've got 5.44. It's asking us to split it into 125 pieces. So we're going to do 5.44 divided by the denominator to find out how much each piece is worth. And then once we find out how much each piece is worth, we're going to times it by 124 because we want the value of 124 of those pieces. And it's a calculator paper, so it's kind of given us that, not ramp up of difficulty level, but it's allowing us to work out 124 125ths on a calculator without thinking, right, oh god, this is going to be tricky, you know, dividing the number by 125. And then so we've got our number here. Don't worry about the million. It's not asking you about the million now. It's almost saying, again, that whole question, if it just showed me that straight away for 3 marks, I'm like, wow, that's amazing. Because I've got to read all this first, I'm like, I don't really care about Tanya's small business. I don't care about it saying a million, because when it comes to the actual math question, there's no mention of a million. There's no kind of million in there. So we're going 5.44, the number, and we're going to work out, first of all, splitting it into 125 equal pieces. So divide it by 125. So it's looking like a really tiny number for each piece. Well, it will be because it's only 5 we're splitting up. And then we're going to multiply it by 124. So we're almost saying it's back to 5.54 again. So times it by 124. Because ultimately 124 pieces out of 125, it's like you've got one piece missing of your jigsaw, isn't it? Equals 5 point, all right, so 5.499, 5.499. So if we look at this now, give your answer to 1 decimal place. So we look at the second number. We're back to where we started.
Yeah, 5.5.
Yeah, which is a really strange one in the fact that it's almost making you question yourself, thinking, oh, can it be the same answer as it was before? Well, yeah, because we've not got that little bit on the end there. We've not got the 4 on the end. So it is almost, you know, 100, it's like saying 99% worth, isn't it? Almost. It's like it is pretty close to what that number's going to be. So when you get the number thinking, oh gosh, that's a bit close. Well, yeah, it's meant to be. So that's the right answer for 3 marks. And I think after doing something like this one for only 2 marks, and I see this one, I think, wow, you know, for 3, that was a better question. Marcus records. So we've had this one similar. No, we haven't. We had one similar to this where it asked you to tell him which one had the most seats available. Marcus records the number of different holiday bookings made by his clients in a 1 month. New, flight only, hotel and flight, returning. What is the probability that the client chosen at random is a new client that booked a flight on a holiday? Give your answer as a decimal. So straight away, probability questions, we normally say, I don't know, 3 out of 10, and that's the answer. Amazing. But this one's saying, great, work it out, but then give me as a decimal, which is basically top divided by bottom equals your decimal. So that's quite straightforward for 2 marks, and it's a calculator paper, so we're okay. So a new client, so we're looking along this line here, new clients that booked a flight and a holiday, this one here. So we're going to go along, and we can see it's 19 news. And we now need to find out, that's our numerator, that's how many it is. And then we need to add all these numbers up to figure out how many it's out of. So we've got 19 on 32, that's 40, 51, 61, 63, 72, 80, 90. Okay, so I would double check that again as well if I'm in the maths exam. So I'd go the other way around this time. I'd go 8, that's 20, that's 39, 49, 57, 67, 77, 8. Whoa. I've got 89 this time. 20, 39, 49, 58, 68, 78, 88, 90. Okay, so I've did it 3 times. So I have got my fraction now of probabilities, 19 chances out of a whole 90. It wants it as a decimal. I'm allowed to use a calculator. I'm going 19 divided by 90. It's not asked me to round it up as a 1 decimal place, 2 decimal place. So what I'm going to do here, I'm probably going to be safe, 0.2111111. I'm probably going to be safe here and just round it up to 2 decimal places because it's a continuous 1. So if I go 0.21, that's as far as I need to go. You could write more if you wish, but I don't need to. I have 2 decimal places, 2 parts. You know, if we're thinking about 1 whole 1 is 100. That's saying that's normal, and it 21 pieces out of 100. So I would be happy at 0.21. You wouldn't need to kind of make it any longer than that, and you don't need to round it up to 0.2 either. It's 0.21. So for probability, that one's quite a visual question. We just got to understand that it's not asking as a fraction; it's asking it as a decimal. The area of the garden is 85 meters squared. The area of the mat is 10.5 meters squared. What is the fraction? So this is a good one for 1 mark. We've got the fraction right there in front of us. We've got it there, look. We've got the fraction, which is exactly what it says. But for 1 mark, we need to remember one thing. We can't have no decimals in fractions. So we can't have decimals in fractions. So there's 2 ways to get rid of that decimal. We either times both top and bottom by 2 and make that 21 and that 170. Or sometimes I just think, I'll just bounce it up 1. So I'll go 105, 850ths. So I just move the decimal place by times it by 10. And you'd get a mark for either one of those. It doesn't matter which way around you go. As long as you can show you recognize that you're not allowed a decimal in a fraction and you've bounced it up or bounced it out, times it out. And that's where the 1 mark is. You're not getting 1 mark for writing the numbers that are in the question. You're getting the 1 mark for converting it into a normal fraction without a decimal in there. And if it had been 0.25, we'd have times it by 4 to get rid of that quarter. Or still, we could have times it by, we'd have to times it by 1,000 then, wouldn't we? 100, sorry, we'd have to go 25. Then another one. So if it would have been 0.25, I probably would have just times them both by 4. A 2 mark cycling. Matt wants to cycle to his friend's house tomorrow. There is a 0.34 chance of the rain forecast. It's not going to rain today. It's blue sky. My washing's out. It's blowing. It's looking good. It might come in a bit cold, but that's okay. What is the probability? It does not rain. So if it's going to rain, so tomorrow is happening. Tomorrow is going to happen. We've got a 0. So rain is here. Not rain is here. And we've got a 0.34 chance. And tomorrow is 1. Tomorrow is a 1. It has to, tomorrow is going to happen. Well, I hope it is. Tomorrow is going to happen. And out of my 0.34, I need to think about what makes my number equal 1. So something at 3 and 4 is 1, which will be 6. 0.66, yeah, equals that number. We've now got a 1. So it not rain tomorrow is 0.66. However, it wants it as a fraction. The easiest way to convert a decimal into a fraction is simply drop the 0 and put 100 underneath it. Because it's 0.66. I've got 66%. So 66% is 66 pieces in 100. That's what that 0.66 is saying. It's saying that's 0.66 of 1. So if it's 0.66 of 1, if I times my 1 by 100, which is there, look, and I times my 0.66 by 100, 1, 2, it becomes 66 pieces in 100. I don't need to shrink that. If you're going to put 33 over 50, yeah, that's fine, but we're talking about probability. So in probability, we generally don't simplify our fractions unless it says simplify your number. If it says simplify your number, we do. But if it doesn't, we look at it as being you're plucking, a number out of a hat, and that's the probability of it happening and the total numbers in a hat. So with probability, the chance is always going to be, always has the two little, if it's a tree like that, we've made a little tree, the little prongs always have to add up to 1. If it's a tree going sideways, yeah, the two little numbers always have to add up to 1. For Mark, so a big one. Mark decides to buy a new bike. We've seen this question a couple of times. What I would say is, again, kind of forget about the fact that he's bought a bike and just look at the numbers. He bought a bike for £441 and 60p. In year 1, it loses 5/12 of its value, so minus 5/12. Okay, that's the first part of the question. I don't really care about my second part yet, because if you look at the second part, in year 2, bikes lose 8% of the value they had at the end of year 1. So it's almost like a backwards compound interest question, where we've got to work out year 1 first, and then another question to work out, another sort of calculation to work out 8% less of that. So let's do that one. If we're taking off 5/12, and I'm kind of thinking out loud here. So if I go 12/12 minus 5/12, I'm left with 7/12. So if I'm looking at that question here, that it's losing 5/12 of its value, it's retaining 7/12 of its value. So I can work it out two ways, and it matters not which way around you work it out, because you're still going to come up with exactly the same answer, but it just saves a little bit of working out. So 441.60 is what his bike's worth. We're going to have to split it into 12 pieces anyway, because it's 12ths. So we're going to split our number into 12 pieces. We consider each piece. So we've done 441.60 divided by 12 equals 36.8. So we know that equals 1/12. So we know that's 1/12. So we need to take away 5/12. So again, we would times that by 5, and doing this the first way around first, times that by 5 equals 184. So we've got 184 times 5 equals 184, and then we're going to take 441.60 minus £184, and we've got the new value of the bike. So 441.60 minus 184 equals, we now know the bike's worth 257.60. Equals 257.60. If that's the comfortable way around you do it, you're finding what your 5/12 is and taking away, that's absolutely fine. What I would say might save you a couple of seconds, not a lot of time at all, but we're going to go 441.60. Still going to divide it by 12, because that's what we're doing, split into 12s. But we know we need 7/12. We know our bike still retains 7/12. So rather than times it by 5 and then take away that number away from 44160, I'm just going to times that number by 7, because I know I'm going to have 7 pieces left. So I've now got the same number there. Look, so I've only saved myself 2 little steps, which will be times it by 5 and then grab that number and take it away. But if you can recognize that if it's losing 5/12 of its value, it means it's retaining 7/12 of its value. So we're working with that number rather than that number, but it's still the same way around. So we would divide it by 12 here, still the same one, and times by 7, and we'd still get that number. So we're now at the end of year 1. We're here, equals 257.60. In year 2, the bike loses, so 2, 5, and hopefully we can do the same sort of thing here. It's losing 8% of its value again. So if we go 100, take away 8, that equals 92. So it's retaining 92% of that value. I know it says it's losing 8%, which is absolutely fine, but we're retaining 92. So we've still got to do it one of two ways. We can divide it by 100 to get what 1% is, times by 8, and then take away that number from 257.6. So let's do that way first. So we've got our 25760. We're going to divide it by 100 to find out what 1% is. So we know that that's 1%, 2.576. 2.576 times by 8 to get 8%, times by 8 equals 20.608. 20.608. So we've now got our new value. So let's take away 257.60 minus 20.608. Okay, so we've now got the value at the end of that. So 236.92. 236.992. That was right. 236.992. Why is that there? I don't know what that number is there. Some box appeared. That's fine. Okay, so we did it that way around. We got divided it by 100, and we times it by 8, and then we took that number away. Again, like this one, saving yourself a couple of seconds could be valuable, but it might confuse you. So if it confuses you, absolutely do it that way, where you find out what 1% is, then times it by 8 to get 8% and take that value away. But if it didn't confuse you, and you think, you know what, I kind of get that bit here, where it's going to retain 92% of its value. So we got 257.60, and I'm looking at this number now, it's retaining that amount. So I'm going to do 257.60 multiplied by 0.92. That's saying I want 92, bless you, if I was a sneeze, that's saying that is retaining 92% of that original 257. So times by 0.92 equals 236,992. So it's exactly the same, but again, it was in many, well, a few less steps. So we just looked at that value here. We think, right, it's losing 8% of its value, so it's retaining 92. When we try to find a percentage of any number, we absolutely times the number by the decimal, not the percentage. So if you wanted 63% of 4 million, you put 4 million times by 0.63, times it by the decimal. Okay, he thinks that at the end of year 2, his bike will be worth less than 53% of its original value. Original value for 1.60 times by 53%, 0.53. So that's how to work out a percentage of an amount, is you get the decimal and you multiply it by it. 1.6 times by 0.53. 234.048 equals 234.048. We've now got our two numbers here. Look, we've got our original value, which is there. Take away 53%, which is here. It's saying at the end of year 2, Mike thinks his bike would be worth less than 53. It's not. It's just a little bit more. It's not massive amount. It's £2 more, but it's maths. So he's incorrect. Incorrect, because it's worth £2 more. For 4 marks, that's an involved question. It's just a case of chunking it into, right, year 1, 5/12, year 2, 8%, and then the comparison part at the end. Okay, Natalie needs to work out what fraction of total number of births in 2021 were registered in the southwest of England for a report. She has this information. Total births registered in the southwest. Round both non-calculator. Round both numbers up to the nearest 5,000. Use your rounded values to estimate what fraction of total numbers of birth are registered in the southwest of England for Natalia. Give your answer the fraction in its simplest form. So we see that the simplest form, hence why it's going to be worth 3 marks. Round both numbers up. Estimate. I mean, it's put 2 of those in bold, so it's quite good. I'm surprised I didn't put that in bold as well. So nearest 5,000. 6, 2, 5, 0, 0, 8. Nearest 5,000 is 6, 2, 5, 1, 2, 3. So that's that one done. That one's easy because it's only 8 over the 5,000 mark. This one, 5, 2, 2, 3, 9. So we're looking at this number here. Is it going to go to 50,000 or is it going to go to 55,000? So if we look at this number here, 239, it's looking at, it's going to go downwards, isn't it? If that had been yeah, if that had been 251, yeah, we think, oh, well, that's over halfway. So if it's over halfway, it'd have gone up to 55,000, but it's not over halfway. Halfway would have been, my brain's not thinking, halfway would have been 251. So we'd go up to the next number, right? So let's get rid of my little 251. So it's going to go downwards to 50,000. 50,000. So our fraction looks quite big. 50,000, 2, 3, 4, over an even bigger number, 6, 2, 5, 1, 2, 3. So we've straight away got a huge fraction on our hands here. We have to shrink it. It's in its simplest form. So
50 over 625.
Yeah, we're getting rid of all that. We don't need that because that's not needed. So we've now got 50 over 625. We've shrunk it. And then we can see that both, if you divide by 5, it has to end in a 0 or a 5. So they both definitely divide by 5. 50 divided by 5 is 10. 5 times 10 is 50. This one, I'm not sure off the top of my head. So I'm just going to go a quick bus stop for 625. 5 into 6 is 1. 1 left over. 5 into 12 is 2. With 2 left over. 5 into 25 is 5. So I've now shrunk my fraction into 10 over 125. Is that the smallest it goes? No, because they're both ending again in 0 or 5. So I know they both divide by 5 again. So 10 divided by 5 is definitely 2. So I've done that. And then 125 divided by 5. Again, not really going to be risking that one. So 5s into 12 go twice with 2. 5 into 25 goes 5. So I've now got a fraction from 50,000 over 625,000 is 2/25. Amazing. I mean, who'd have thought it? Look at that number, then look at that number. You think that's not the same, but we've just done an equivalent fraction, shrink and shrink. And we can see now that that's an even number, that's an odd number, so they're not going to go any smaller. So the final answer for 3 marks in its simplest form is 2 over 25. So 2 out of 2/25 a birth are in the southwest of England. Okay, have we got time for you? We've got time for I got Mark. Oh, the computer just said, what did that say? Alert. Oh, do not disturb. Weird. Charlie plans a road trip along Route 66. Oh, this is the one we had the other day where we're talking about proportion. He looks at online flights to America. Charlie thinks the afternoon flight has a higher proportion of seats available. So it's, again, comparing. It's a calculator paper, so we don't need to worry about the whole changing the denominators into the same number. So this one's got 338 available over out of 416. It's the morning. The afternoon is 396 over 528. I don't know about you. I was watching this amazing. The world record on Saturday. There's a young lad and this machine generates 4-digit numbers. 4-digit numbers. He has to add up 100 of them in his head in the fastest time possible, and he did it in less than a minute. It was on average. On average, the numbers were churning out at like 0.6 seconds. So every 0.6 seconds, there was a 4-digit number flashing on the screen, and he was memorizing it in his head, adding it up, adding it, adding it, adding it up, and he got it right. After 100 numbers, he typed his number into the keyboard, and he got it right. I'm like, oh my God, that is like so. Ah, young Indian lad. It was just amazing. I'm like, wow, that is Matilda type maths. Is that? That's just amazing. I mean, not that I could
They're really
attempt.
good maths, I think.
It's just amazing. Like even like the primary schools, they do like what's called TT rock stars, and you got to do your times tables quick. And when Olivia was doing it back in primary school, I used to have a go, and I'm like, there was some kids in like year 6 that were, I don't know if it was their parents doing it as well, but I'm thinking, wow, you are doing times tables at like less than half a second to get your times tables right. I'm like, only up to 12 times 12, but it was still like, again, amazing speed. I'm like, if it was the kid that was doing it, maths genius incoming. If it was the parents doing it like me, just for a bit of fun to sort of challenge yourself, then you're beating me. So we do the top number divided by the bottom number to get the decimal, 0.8125, I think it was. Or was that? That's not what I saw. Yeah, let's see. And then that one, 396 divided by 528 equals 0.75. So we can see by changing them both into decimals that this one's a bigger number and therefore has the highest proportion of seats available. He says the afternoon flight is incorrect. Why is he incorrect? Because we've just proven it, because the morning is 0.8125 and the afternoon is 0.75. If we looked at those two fractions, again, we could divide them both by 2, and then divide it. You can get it so that they're looking like something like fractions you could definitely see, but for me to change them both into the same denominator, I'm thinking, wow, where would you start? You know, you could start, if you had a calculator, I mean, a calculator, where's my calculator gone? If you had a calculator, you could definitely times them both together. 416 times by 528 equals. So you're looking at 219,648, which is just bizarre. You would never do. Well, you could, if you did it like that. If you did it like that, you'd have, so 219, oh my gosh, 648. That's your bottom fraction, 219,648. We times that one by 528, so we need to times this one at the top by 528. 338 times 528 equals 178,464. 178,464. We times that one by 416, so we need to times the top one by 416. 416 times 396 equals, whoa, that can't be right. 416 times by 396. Thinking, wow, bad numbers on my calculator. 164,736. So we've now done it a different way around, and we can clearly see if we did it that way around and got the same denominators, we can again see that this fraction is larger by some crazy amount, by 14,000, but we did it straight away by dividing top by bottom and got 2 decimals. If we did the same here, we'd get the same decimals. Because it's the same fraction, we've just made them equivalent, as in like the same denominator. So for me, the top divided by bottom to get my decimal, I can straight away see from looking at those 2 decimals that one is larger. When I've changed them to fractions, yes, I can see that one is larger, but it took me a little bit longer to do it. Private tutor. Marco is a private science tutor. He puts his data on his website. Work out 161 as a percentage of 175. it's told you it as a fraction. It's said to you that 161 people out of 175 pass. We divide top by bottom to get our decimal. And we times it by 100 to get our percentage. So it's no different here. We've got our top number 161 divided by 175 equals, that's our decimal, times by 100, that's our fraction, 92%. That's our percentage, sorry. So we've got 92%. And that's for 2 marks. We recognize it as a fraction, do it as a decimal, times it by 100, and that's what we'd get. Jake recruits. Okay, so again, all this, I'm not saying all this is irrelevant. I don't mean to sound rude to NCFE, but it really is. Jake wants to know which supermarket has the highest number of applicants for each job. He thinks that 75/12 is larger than 93/15. The only tricky part about this one is it's non-calc. Okay, so we're saying here that 75/12 is bigger than 93 because the crocodile eats the largest number. So he's saying that that one's bigger. If we're looking for numbers that they both go into or divide by and things like that, the quickest thing to do is go 12. 2 times 12 is 24. 3 times 12 is 36. No. 4 times 12 is 48. No. 5 times 12 is 60. Amazing. So we've got a 0 on the end. So if we put them both into 60s, we're okay here because we're now going to work out directly if that is bigger than that. And we've done it quite quickly. You can sometimes, like we did on the one above, we just multiplied those two together to find the denominator, but that means you're timesing these by bigger numbers. We've worked out that 60 is part of both the times tables for both of those, 4 times and 5 times. So we're going to do, we multiplied that one by 5 to get there. So we need to multiply this one by 5 to get there. So 75 times 5, if you go 75 times 5, again, we can do it in a normal one. 5 times 5 is 25. 7 times 5 is 35. Add our spares is 37. So we can see that that one becomes 375. And this one, to get to there, we times it by 4. So this one, we also need to times by 4. 93 times by 4. 3 times 4 is 12. 9 times 4 is 36. Add our spare, 37. So we've now worked out our numbers in our equivalent fractions. 375 is bigger than 372, so E is correct. Looking at those numbers, we can't tell, but now we put them into the same denominator. Only just. Is he correct? Yes, and we've shown how we decide because we've changed them both into the same denominator. How do we times them both by each other to get to, I don't know, 12 times 15? 12 times 12 is 144. Add another 36, 190, 80, 180ths. We could have gone to 180ths, but then we're timesing that by 15, timesing that by 12, and becomes much bigger numbers. But you can do it. It's just a case of setting out your multiplications to the next of it. Right, and this is the last one. 120 carers took part in a survey. 104 of these carers thought the job was rewarding. What fraction of the carers thought the job was rewarding? Straight away, for 1 mark, we've got 104 over 120. It doesn't say give your answer as the simplest fraction. So I'd be tempted to leave it at that. And I don't know if that's going to let us do it. So this is 1761 4D. 1761 4D. 1761 4D. I mean, why wouldn't it let you keep it like that if it's not said simplify it? 4D 4D 4D. Yeah, it's let you keep it at 104 over 120. So it's let you keep it as that. So unless it says simplify it, and it's only worth 1 mark, so that's what makes, sometimes when I think it's for 1 marker, it's asking to say what you see. If it's for 2 marks, maybe, then it would have said simplify it. So would have looked, oh, I'll divide both by 2 to start with, and that becomes 52, and that becomes 60. Oh, well, there's still even numbers. That becomes 26, and that becomes 30. Oh, there's still even numbers. Divide by 2 again, that becomes 13, and that becomes 15. So when we divide, when they're still both even at the end, the quickest one is just divide by 2 each time until you get to one that's not even and think, ah, actually 13 is a prime number now. It doesn't go any smaller than that. But when it's only for 1 mark, that bit's not relevant. You just say what you see. Right, I'll save that. And I'll send you the recording. I mean, pick another exam or something like that, or pick another, sort